Hi everyone, let's calculate the integral of cosecant of x, which is equal to the integral of 1 over sine of x. And we see that we have a rational expression in terms of sine, therefore we can solve this integral with the Weierstrass substitution. That is to introduce a new variable. Let's say t is equal to tangent of x over 2, and we can construct a triangle from which we can express later on sine and cosine, etc. And that is, let's construct a right angle triangle, and we know that the angle is going to be x over 2, and tangent of an angle is given as the opposite over adjacent. In our case, the opposite is t, and the adjacent is going to be 1. So therefore, the hypotenuse is the square root of 1 plus t squared. All right, let's try to differentiate this guy. And this will give us dt is equal to 1 over 2 times secant square of x over 2 dx. And let's try to express secant of x over 2 in with our triangle. We know that secant is just 1 over cosine, and therefore we have to take the reciprocal of adjacent over hypotenuse. In our case, this is just secant of x over 2 is just equal to the hypotenuse over the adjacent, and that is square root of 1 plus t squared. Now we can plug that into this form and rearrange after dx. So dx is just 2 times dt. Now we have to divide by secant square of x over 2, and secant square is square root of 1 plus t squared, and square it. So the square root will cancel. Then we have 1 plus t squared. All right. Now we found the expression for our dx, but our integral contains sine of x. And in order to express sine of x in terms of sine of x over 2, we actually need to take the double angle identity for sine of x, which is, we can say that sine of x is the same as sine of x over 2, but we need to multiply this by 2. So this gives us, this is the double angle identity of sine of x. This is equal to 2 times sine of x over 2 times cosine of x over 2. All right, now we need to express sine of x over 2 and cosine of x over 2 with our triangle. So let's try to do so. We know that sine is given as the opposite over the hypotenuse, so therefore we have that sine of x over 2 is equal to t over square root of 1 plus t squared. And we also know that cosine of x over 2 is given as adjacent over the hypotenuse, which is just 1 over square root of 1 plus t squared. Now we can plug both into this integral. This will result in, well, we have in the numerator we have 2 times t times 1. This just gives us 2t, and the denominator we have the square root of 1 plus t squared times itself, so this just gives us 1 plus t squared, and this is equal to sine of x. Okay, now we can plug everything into the integral. So our initial integral, let's call this guy just I. So I is equal to, now we have sine of x, and here we have the reciprocal of it, right? Then we can just flip this. Then we get 1 plus t squared divided by 2 times t. And for dx, we found out that this is 2 times dt divided by 1 plus t squared. So let's plug that in. We have 2 over 1 plus t squared. And here we have dt. And we see that basically everything will cancel out gently. And so we are left with the integral of 1 over t with respect to t. And this is just natural log of the absolute value of t plus c. Thank you for watching.